Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Christophe Sigrist is a professor of timber design and steel design at the Bern University of Applied Sciences, and he's the director of ongoing research work in undergraduate and postgraduate projects on the real cutting-edge timber design. Now, new technologies in design software and robotics are really unlocking opportunities for complex structures that were previously unavailable to building professionals in the past. So in this episode with Christophe Sigrist, we discuss what are some of the new capabilities of generating complex geometries and automating the structural design for these geometries, and how skilled craftsmanship combined with advanced robotics can build these really complex structures, like the Swatch building that's in Switzerland, which you're going to hear all about. So this is a really forward-thinking conversation about what's coming for timber design, robotics and prefabrication and so forth. So I hope you all enjoy the show and learn as much as I did from Christophe. And without any further ado, we'll get into the interview. What are some of the notable projects and developments that are happening currently in Switzerland and Europe?
Well, there are many projects on the way. I think one of the big area of projects are something like free shape structures, which is a very specific area where many companies are involved, but also on, let's say, mid-rise, high-rise, multi-story building. There are lots of activities. I just visited one site last week, which is a 15-story building that is close to getting finished. So the system is basically that there's a concrete core, but all the rest is timber or timber-based solutions. So there are column systems in either hardwood or engineered timber products and timber concrete floors. So it's a good mixture of different materials. Well, of course, first off, the properties of the material must match. We have to think about deformation when you're going to this height, elastic deformation, or also deformation due to moisture content. This is certainly one thing. Other very important things are, of course, all the issues of building physics, fire safety, and so on. So basically, we are in the same problematic as any other high-rise building.
And you mentioned deformation being one of the issues when you get to such tall buildings. What are some of the solutions that you can use to mitigate some of these risks or technical issues when you get to these heights?
Well, some of the secrets is certainly to prefabricate all the elements in order to get good accuracy. And then secondly, we try to dry the timber to the environment or the possible environment where the timber is going to sit in. So that means if you're looking at domestic buildings or even apartment buildings, we know that the buildings are going to be ventilated, heated. So we expect moisture content of about 9%. So we will prepare the timber to that moisture content, produce it dry, move it to a site, avoid any change of moisture content during erection, and then keep it dry. I think this is one of the secrets. And if you respect this, you shouldn't have any major problems in the end.
Yeah, great. And another project you presented and talked about at the workshop was the Swatch building, which I understand is a complex structure. Can you tell us what some of the details about this structure and what it looks like?
I think you better look at photographs for that. Go to internet and Google the building. I think that's probably better. But let's say just in a few words, it's a very complex structure. It's spanning 25 meters across, and the entire length of the building is more than 100 meters, and it's kind of like a snape type or shape we are looking at, and the structure or the geometry of the structure is just fully free. There is not an apparent rule, free shape, and try to find a solution with in using timber. So in order to get this complex geometry, we need to work on the timber. We have to cut it, to size it, to produce it to a special shape. That means that we will have in the end multiply curved timber members intersecting to each other, which makes the whole thing very, very complicated, of course. Well, you have to really separate, let's say, that all the design steps you start looking at, and then you have to attribute the tasks to the different places, and you would need someone who is able to merely produce these elements. And as you said, out of these 2,500 elements, not one was similar, but I think in the end, what we have a piece of timber that comes onto the site. You know exactly where the attributed position is, and with some skilled carpenter, skilled building persons, you can erect it according to the erection scheme. So once everything is on the computer, everything has been digitalized, you go from there, and the path of construction is actually drawn pretty nicely.
And with it being on the computer, what is the digital workflow, and what are the techniques used for the design process to get such an amazing looking structure with 2,500 different elements?
Yes, so there are a couple of key issues. One key issue is just to find the right geometry in order to have a nice smooth surface. So this is the first step you have to look at. The second step would be to try to match this geometry with some static needs. You might remember that earlier in the world, many dome structures were built. A dome structure has a particular shape, and this shape matches very nicely some strength capacities. So there are some very famous structures, or people taking fabrics, freeze them, try to find the best natural shape, and then take this shape as a basis to create a structure. So these were perfect shapes to match geometry and static border conditions. So in this new structures, it's a little bit different, because you have a certain geometry which you try to get organized using some programs. After that, you have to match it with the static calculation programs, switch back and forth, and try to find a solution that suits both requirements. And once you have that, then you can start programming for construction or for production first. And overall, you have to think right from the start about the capabilities of the timber, the strengths and weaknesses of the timber, and also about how you're going to put these things together. So there's switching from one requirement to the other requirement non-stop until you find a solution that seems to work.
And this new process of digitalizing the workflow, where you're using computer software to generate the geometry, but also do some of the design. What new opportunities does this unlock, and how is this easier compared to, say, the engineers a few decades ago designing these big dome structures?
Yes, I think the main interest is just to not have to bring your structure right down to a very regulated geometry or shape, so that you are free to kind of deviate from that and still trying to get a good solution. So I think the most interesting part of it is, of course, getting these free shapes. But another big advantage of linking different softwares and tools is also to really define the geometry and to have the cutting following afterwards. And working on the preciseness or the accuracy of the structure. So at earlier stages, you always needed some tolerances, but these tolerances are really brought down to a very, very small amount. So that means that everything fits, and in the end, you will have a perfect geometry in your structure.
With the robotics technology, how does the process of the robotics actually work, and what level of detail can you get to using robots to cut the timber into the unique pieces?
Yeah, I think we have to divide two things. One is the robot, and the second thing are all the other tools like cutting centers. So in the end, we don't have one tool doing all the job, but rather having an interaction between different tools. So in the cutting center, you are free to shape your timber and to get all the connections done and to have this very, very high accuracy. So you have basically a kind of a fixed installation. And the robot is in many cases used as an annex tool, if you like. So the robot might, for instance, in a setup where you start also constructing with robots, he just might merely take a piece of timber and move it from one fixed installation to the other. So this is kind of a normal arrangement. The problem is a little bit that you have to be careful about the size and weight of members you're moving around, because any weight on an arm of a robot will have or give you problems with accuracy, with positioning, and so on. So I think it's these setups which are quite interesting to look at, to have maybe some things done on fixed installations where you have all the freedom and accuracy needed, and the robot being just an extra hand and doing things a human couldn't do.
Mm. And in what scale do you envisage the robots might be, and this technology be used in the future, and how much do you think can be automated of the whole construction process?
Yeah, I think as long as you're sitting in a fabrication plant, you can use the robot. But the robot, he has a limited reach, so he can travel along rails to get from one point to the other, and then he has also some possibilities in reaching certain points. So within this area, you can have one or two or three robots doing things like bringing material, or nailing material on supports and things like that. So we have done some testing together with ETH Zurich, looking at what are the fields, or what is the size of field you could cover with a robot, and you're limited for the moment quite quickly. So we were working on areas looking at maybe something like 6 by 6 meters, where the robot can easily get to different locations and do his work, and you can actually also master the accuracy of this work. And there is one quite large structure, probably something like 6 meters high, structure that was built entirely by robots, but this structure would sit on a turn disc or a disc to be moved around, turned around, so that the robot is able to get to different points where he has to bring in the members. So I think for the moment, the robots are still limited to rather small geometries, and having some tricks to get to some average geometries. But in the end, say moving around big pieces and covering large distances, I think this is still in the way of being developed.
That's exciting. And when you're in Australia, and I saw your on your university master's course website, where you're talking about Industry 4.0, which is the fourth industrial revolution, and some of the opportunities surrounding this. So can you talk a little bit about what this actually is and what the effect of this revolution might be?
Well, apparently everyone is moving towards this direction. I think we shouldn't be fooled. We still will need people working on site and doing work by hand. But I think Industry 4.0 is probably the key to moving around data, to bring data from one point to the other, to have interfaces between different trades. And also, I think one of the very big advantages having all or everything digitalized is that you can update your files. If something goes wrong during your production or erection, you don't reach the accuracy required, you can actually create loops and trying to do or take some measures in order to correct the way of your construction is going on. This is certainly one of the big issues and the big goals to solve. And another one is also that, of course, everyone is talking about the same basis. So we have the same model. We have many trades being integrated in these construction processes. So it is, of course, very important that everyone talks about the same thing, and that people talk or use the same platform, the same data, in order to avoid that pieces are on the wrong place, or that in the end you cannot get the solution because you have intersections that don't work, connections that don't work, or that merely some of the items are going to be in your way. So I think with this respect, this will be a great advantage in having solutions in a digital format. And this is a little bit the understanding of 4.0 from my perspective. But 4.0, of course, is also just having some of the robots or some of the aids interacting, working together. I think the image everyone sees are these big conveyor belts and cars being built automatically, where every little robot has its little task. But I'm not sure if with what we are looking at in our complex structures and the way we are building currently with timber, that we're going exactly in the same way. So I think we would also have to develop a solution which is suitable using timber as a construction material, to marry it with other materials and to get an optimized economic solution.
Absolutely. And as we come toward the end now, what are some of the thoughts that you have on the overall timber construction going forward in the next few decades?
You can also think about the future of timber construction. I think for the moment we are already in the future. We are looking at things that haven't been possible decades or even a couple of years ago. And I think, as I just mentioned before, that the next step in order to be able to use timber in many applications, that could be from very simple applications like pieces of furniture or very small structures, going right through to warehouses or multi-story buildings. I think we cover already the width of it, but what we will have to be, or where we will have to be very precise and maybe a little bit cautious, is that we have to try to find the most suitable applications. Where are the places where our constructions are economic and cost efficient, and also in what areas can we get the best performance in terms of serviceability, safety with our construction material. And I think there, as for other materials, we have some strong points we can cover with our construction materials, but maybe due to the reduced weight of our construction material, we might get into more bigger problems of vibration or acoustics. But I think also these things can be solved. There are many people looking at 40-story buildings. I think a 40-story or 80-story building can probably be done in timber, but the question is it still economic and cost efficient, or can we take this 40-story building as a kind of a playground to develop a toolbox we need to deal with any other, let's say, standard constructions, which could be, in our case in Switzerland, 4 to 8 or 10-story buildings for commercial or other domestic usage. I think this is a little bit what we have to look around, and not necessarily trying to put the timber at any possible place, but really, as I said right in the beginning, try to find the place where the timber has best possible performance, and trying to work on that and marry it with other materials in order to find good overall solutions.
Yeah, absolutely. And we've had a very forward-thinking conversation about all these exciting developments in digitisation and robotics and so forth. What do you think are some of the most important skills building professionals may need to have to be very relevant and highly valuable in the future of construction?
I think that we still need skilled people. So I think the way we are doing it for the moment in Switzerland with these dual educations, that we have some people who follow university tracks, entering into research and teaching. But on the other hand, we have also a lot of people who have good skills working by hand. So we have to properly educate them. And we can also see today that the carpenters or joiners are also moving towards these new techniques and technologies. So even in parentheses, a simple carpenter, he is aware of high-tech solutions. He is aware about machinery being able to do precise work. But then we also need these guys to talk to the machine, to do the work in the factories in order to get the components being built in a right and correct and accurate way. And I don't think that we can replace skilled people even in the near future by just any machine doing something kind of similar or in the same or close to the same way.
Mm. And can you tell us a little bit about the master's course that you have over at Bern University in Switzerland?
Okay, so the master course, I think here again, Switzerland is somewhere at the top place when it goes to research development, new exciting structures. And what we try to do in our situation, in our school, so we have all the background, we have all the experts. We also try to bring our education right to the top level. So the future is already kind of installed in our master courses, and we address in our course the hot topics which are around. So that is digitalization, BIM. To be also taught at this level. We are looking at complex, simple structures, and we also try to use all the software that is available in order to try to find a solution for that. So we give to our students very high-end tasks or assignments to be solved, where they have to play around, work around all this very, very wide field of requirements and possibilities, and try to find a solution that works in the end. So I think in that sense, the future of teaching has already kind of reached also our education. Of course, there's still many other ways to look at that. We're currently trying to restructure our education in thinking what are the best ways in getting the information to the student. Is that still a kind of a teacher to student presentations, or is it more like discussions, project work? So we're going to try to find out the best ways for the students to get all this big heap of knowledge and try to be able to use it in order to produce something in the end which is exciting timber structure.
So if you want to learn more about timber yourself and upskill, I suggest that you go to the Wood Solutions website to check out all the technical design guides. Right now there is 47 of them. One of the most recent ones, guide number 46, Wood Construction Systems, being a very good start for the conceptual design of timber buildings.